Okay, now welcome to question 7b of the 1998 3-unit paper. Now this has got 3 parts into it, so I'm going to do a video for each part of this thing. Alright, so the first part of the question asks us to use the substitution y equals the square root of x to find the integral of dx over the square root of x outside of 1 minus x. Alright, so this is our standard u substitution question, except we're using a y instead of a u, so it's nothing too special. So what we'll work with, we work with our substitution first. So y equals x squared. So to get rid of that x square root, we're going to square both sides. So we've got y squared is in fact equal to x. Okay, now what we can also do in this situation is that we're going to differentiate y with respect to x and differentiate square root of x with respect to x. So that just simply gives us dy over dx is equal to 1 over 2 square root of x. So you can do that with your index and use the chain rule, but I've just done it quickly just to save time. So we know that dy over dx is equal to 1 over 2 root x. Now if I cross multiply both sides, I'm going to end up getting that 2 square root of x dy is in fact equal to dx. But what was our square root of x? That's actually equal to y. So I'm going to replace the square root of x with y and get that 2y dy is equal to dx. Hey, that's pretty easy because now all I have to do is substitute dx with 2y dy. Alright, so now we'll be moving on to our substitution because now we found that x is equal to y squared and that dx is equal to 2y dy. Alright, so with our integral, now I'm going to substitute this, so we know that dx, so we'll say equivalent, we're not going to say equals to, equivalent's more of a better way of saying it. So dx over square root of x1 minus x is equivalent to the integral of, now dx is 2y dy, and that's now over the square root of, now we've got x, so that's y squared, and that's also outside of 1 minus, now x again is y squared. Okay, so now if I simplify this a bit easier, so now we've got, because you know that the square root of a square number is in fact the number itself, so that's now going to equal to, so I'll take the constant out of the integral, y dy, and now again square root, so y outside of 1 minus y squared. And look, the y and the y, they will cancel out, so I'm going to take those two away, and what am I left with? I'm left with dy over the square root of 1 minus y squared. That looks pretty familiar, don't you think? Yes, it does, because that is this is in fact equal to 2 sine, inverse sine, y plus c. That's just your standard integral. That the integral of something over 1 minus y squared is in fact equal to the sine inverse of that y. Alright, so now that we're almost done, because we need to leave it in terms of x, we remember that y is equal to square root of x. So the last step of this is to say that that is actually equal to sine inverse square root of x plus c. So there you go. You've shown that dx, the integral of dx over square root of x outside of x 1 minus x is equal to, so that's ugly, equal to 2 sine inverse the square root of x plus c. So that's the first part of the question done. Now we'll be moving on to part 2.